Hi guys, Crafting Redstone here, and today we're going to have a look at Redstone Memory. So, let's start. Redstone Memory uses NOR gates, and it's called an RS NOR Latch. And what this means, whatever signal you put through the RS NOR Latch, it will permanently change signal until a different signal has been put through it. So you can see, you can put this one on twice, it still won't change it. Put this one on, and it will change it. Even if the lever is off, or if we use a button, for example. Let me just grab a button. So even if we use a button like this, the button goes off, it will still keep the signal on or off. So this is what is meant by remembering what signal goes through it. And that is just a very basic RS NOR latch, and it's just set up like this. So let's have a look at a few different types. This is another type of RS NOR latch. This is a vertical one. It's all in one block, except from levers, but they don't have to be there. And as you can see, we've got input A and input B down here. So if we do change that lever to down, it won't change because that signal's already on. But if we change that lever, it will remember that we've just put a different signal through it, and it will change the repeater output. And that's basically how this one works, just the same as the other one, just a vertical format. And it's made just like this. So redstone into a redstone repeater, going into a block, into a redstone torch with a block on top, so it can power this redstone wire into a torch, will then can power this one down here. So now we move on to some more complex RS NOR latches. As you may know, droppers can drop items what are inside their inventory. So this is very useful for a number of things, but there is another function with droppers that if you have them both facing into each other like this, but this one just one block closer like this, and you do need another block in it so it doesn't power both of them when you're doing this, it will actually get the block, what is in my inventory, and it will push that block into the other dropper, as you can see. So it doesn't fall on the floor, it goes into the other dropper's inventory. And this isn't so useful for a lot of things, but for one particular thing it is very useful. And after 1.5, comparators are added, and this basically can get a output of a redstone signal if it finds some object in the dropper's inventory. So as you can see, we place that there, we get an output. But if we change the dropper, what it's in, back to the original one, so the item's in this one now and not in this one, we do not get any output from it. So this is very, very, very useful in creating RS NOR latches for Minecraft builds. And you can do this anyway, so you can have vertical ones as well. They don't have to be horizontal, but you do have to have both the droppers facing into each other. So let's have a look at how you can make one of these. This is a basic setup of an RS NOR latch. So as you can see, we've got both inputs, so red and blue, and depending on the input, it will change the output. So off, even if that one's off now, you can see it's changed, so it's on, and change it back. And you can compact these a lot. So if we wanted, it's basically set up in the same way with all the items in here, in different places though, and we've set it up so they're all next to each other, so we can have different outputs. So if we reset this one, so all the lamps are off, and then we can put in different inputs. So I don't know, probably that will do. As you can see, they've now gone in and remembered that input. So even if we turn these off now, you'd expect generally with the redstone signal for the lights to turn off, but as you can see they remain on because these items are now in this dropper. So if you then put that, you then, oh, 1 minute, sorry, misclicking. My mouse isn't so great at the moment, so you might notice me misclick on a few things. So as you can see, then you put the other input on, and it will send all these items back into these droppers here. And that is how this works, just on a much larger scale. So let's take a look at that. Now I mentioned a few times now different inputs and outputs, and I colour code a lot of my redstone projects. So if you see, for example, blue or red, that indicates an input. If you see a green, that indicates some sort of process or logic gate. So as you can see, this RS NOR latch is in green because it indicates some sort of process or logic gate. Then yellow is the one what I use very interchangeably. And basically, if it's an addition circuit, so an XOR gate and an AND gate, I will use it for the carry ins and carry outs of that addition. So what that means is if I had, well, it basically has an input C or an output B. And what I mean by that, if we've got two main inputs and they're getting added together, we might, if we get adding 0 and 0, we'll get 0. If we add in 1 and 0, we'll get 1. If we get adding 0 and 1, we'll get 1. And if we add 1 and 1, we will get 2. But three out of the four of those only consist of one digit in binary. But 1 add 1 equals 2, and 2 is 1, 0 in binary. So the 1 will act as a carry out or a carry output and go back again into the sum of the next one as the carry input. And that's why I use for yellow. But yellow also can be output C or the main output like this one here, or a third input. Moving on, black indicates an on or off of the system. So this one here will either turn the Redstone memory on or off. And finally, the last two are the purple is input D. So this is input D here, although we've only got 3 inputs, but yeah, this is input D anyway. Or input C, could be a third input, just another input besides input A and B, the blue and red. And finally, magenta can be the secondary output. On this example, we don't have a secondary output, but we will do on other projects. So that is the colour coding for my Redstone build. Now to have a look at this. What this consists of is 8 rows and 5 RS NOR latches in each one. So how we choose between these rows is with a binary decoder featured in a previous video, and I think that might have been video 3. So check back on my Redstone tutorials and it should be in there. I use a binary decoder to select which row of RS NOR latches to choose from. So what happens if we turn the system on, because it is currently off, and we put in a random number there, but it is 6, we will find that this is 0, this is 1, 2, 3, 4, 5, 6. So this then travels through, and you see it's the only redstone wire turned on or repeater, and this goes into a redstone torch tower. And this redstone torch tower goes all the way nearly to the top, and it moves along here and pushes these pistons down what act as AND gates. And this allows the redstone signal to pass through and will change the RS NOR latches. Then if we have any output from these RS NOR latches, it will also let them pass through and go back down into these downwards redstone torch towers. I'll show you how to do those later on probably. And they're very simple. I move along here and come to the outputs. So for example, I will put loads of different combinations into this and demonstrate it in a minute. And I didn't really mention the on and off switch is very simple. It just turns on and off the redstone decoder, so there's no inputs coming in here, so that means there can be no output from the AND and NAND gates. So that's how the on and off switch works. Anyway, let's have a look at these RS NOR latches. I've put in a bunch of, well, not too random, I've just done it 1, 3 and 5, 2 and 4, 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, so on and so on. And basically what it's done is remembered these inputs. So I've got 1, 3, 5, 2 and 4, 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 5, and 3. So what this does is it receives the inputs from these buttons here. So if we turn it on, I'll just give a quick example now that they're all in there. So we picked another random configuration. So we'll do 5 for example. We will get the output once it's loaded. Should be 4. Yeah, 4 there. So it's got the output from the 5th row and travel the signal all the way down here to the output. So let's have a look at this. And very quickly, in this example here, we have this blue thing here, blue signal here, what resets the RS NOR latch. This is basically just this one here. So you press that and it'll reset it all. And we are going to put in a configuration of redstone signals. So if we did, let's put on the first one, that's it. So on the first row, we're going to press the button. It's going to have the signal what's now off because it's a button. Actually, I can change that to a lever and just show you how it all changes. So if we find a lever and we replace that with the button and turn it on permanently, then we get this signal passed through here, and it's from the redstone torches because it just inverts it, so it's easy to use in a minute. And it goes into redstone torch, inverts it again back to its original. So as you can see, this is the only one on because this is the only input we've put in. This then can pass through the piston because there's a block there. If there wasn't any block there, it would not be able to pass through. This goes into a block then, what means only this side of the RS NOR latch is powered. What means the item, instead of being in this one like all the others, is now in the other one. If I can get under there, as you can see, it's now in this one here. So what that does, it has a comparator output. Well then again, sorry about that. Well then again, can go through the block because there is a block there, and pass through here. But because none of the other RS NOR latches are on, as you can see, no other redstone repeaters are on. This then travels down here, and ignore this redstone torch here and the redstone wire, as this just transfers the signal down from up there. And that travels across here. It then goes into this block here, what inverts the signal. As you can see, this redstone wire is on, so this redstone torch is off. This redstone wire is off, so this redstone torch is on. This signal then travels down here, up to here, which is a redstone torch tower. And this basically swaps it around, so as this is on the left here, it's now on the right. So this signal is on the left of the fire, we'll just make that clearer. This signal is on the far left, and if that continued in a normal redstone circuit and came out down here, it would still be on the left, but because we've used this here, it inverts it to put in the right binary order. So we get the right order of the number back out, because if it was the other way around, it would be a completely different number to what we put in if it was binary. So this then gets a signal and it travels down here. The blocks are just there because it looks nice. They are useful for transferring redstone data as a signal, but I just put it there because I did. And then this powers the redstone lamp here. So if we were then to put in a different one, like this one here, this will then also travel through here, and it's a lever, so it went off, and it will move the item across into this one instead. We'll then have a comparator output and do exactly the same thing. But if we wanted to select a different line, see how these pistons here are extended, but these ones are not. If we then put it on a different line, so let's do line 2 for example, or 1 in binary, but we've got 8 different combinations, so we've got, yeah. And then didn't mean to do that, but I have, so oops. So we're going to have this on here for the line 1. Anyway, if we then put in a different input, so this one here, you see the pistons are, this is not line 2, this is line 2. The pistons are extended so the signal can travel through, what also changes the item in the dropper, its location, and then has a comparator output, and then travels down these redstone torch towers. And this then does the exact same thing and travels along here and down across here to the redstone lamps where we get our output. So let's have a look at these torch towers. Now I've used these a lot, but I didn't always know how to do them, and they're fairly simple, but I thought it was quite important for people to know how to do them. So what basically happens, if we have a redstone torch there, it will power this wire here. If we also have a redstone torch here, it will power this wire here, but it will not power this wire here because it's not adjacent to it. So it can power the ones all around of it, so like that. And this is how these redstone torch towers, what go downwards, work. We've got a block, and then 2 blocks down from it and 1 to the right, or 1 either side, we have there. And then we have a redstone torch in this one, what can power the redstone wire on top of this one, well then consequently turns off the redstone torch here, what then can go into a different one, travel along, and if we wanted to keep it going a lot that way, or have it going down again, this will then keep this redstone signal on. So if we then turned, we don't need that one on top because it's the first input, but if you're going to carry it on and extend it, you would have that redstone wire on top. If we then change this one, as you can see, this redstone torch goes off, so this redstone wire is off, means this redstone torch is on, what then means this redstone wire is on, what means this redstone torch is off. And that's how that works. Very simple and very, very, very useful. So, thanks for watching. I hope you've enjoyed this episode of Redstone tutorial. And if you do enjoy it, please don't forget to like and subscribe. And I'll see you next time from Crafting Redstone. Thank you. Bye.